Hello guys, hope you are doing great. So in this video I'll be discussing about Skinput Technology. Let's dive into the video. Table of contents. I'll be covering all these things over the course of time in detail, right from introduction to conclusion. Introduction. Skinput is a technology that uses the skin surface as an input device. To capture this acoustic information, they developed a wearable armband that is non-invasive and easily removable. It was developed by Chris Harrison, Leslie Tan, and Dan Morris of Microsoft's Research Computational User Experiences Group. Skinput allows the user to simply tap the screen in order to control audio devices, play games, and make phone calls. It uses sensor to determine where the user taps on the screen. Its first public appearance was at Microsoft's Tech Fest in 2010. More than a touch. On body contact with skin, generally it opens up to a new and unexplored interaction space. As our skin is stretchable, it allows for additional input modalities such as touching, grabbing, pulling, pressing, scratching, sharing, squeezing, and twisting, which we see in the given figure. This increases the input space for on-screen interactions and enable more varied forms of interaction. Principles. It listens to the vibrations in your body. Skinput also responds to the various hand gestures, and the arm will be used as an instrument. Armband detects the acoustic signals and converts them into the electronic signals, which easily enable the users to perform simple tasks like browsing through mobile phone menu, making calls, controlling portable music players, etc. How it works? Basically, it consists of three major components. There are Bluetooth, Pico projector, and bioacoustics. Let's discuss each and everything in detail. Bluetooth. The armband is connected with the device with the help of Bluetooth technology. It is used in the Skinput technology to transmit the information from the armband to the device so that the device functions accordingly. Pico projector. A Pico projector is a small hardware device that is used in the Skinput technology. It is attached with an armband so as to give the graphical user interface to the user. It is employed as an output device that shows menu or whatever functionality user wants to use according to the tab. It is the most essential part of the technology as it provides the interactivity of the technology with the user. Bioacoustics. Basically, it consists of two types, transverse wave propagation and longitudinal wave propagation. Let's discuss them. Transverse wave propagation. When the finger impact displaces the skin, it creates the transverse waves, which are also called ripples. The sensor is activated as the wave passes underneath it. Longitudinal wave propagation. When the finger impact creates longitudinal or compression waves, it causes the internal skeletal structure to vibrate. This in turn creates a longitudinal waves that emanate outwards from the bone along its the entire length towards the skin. Bioacoustic sensing. How it works. In Skinput, a keyboard, menu, or other graphics are beamed onto a user's palm and forearm from a Pico projector embedded in an armband, which we can see in the given figure. An acoustic detector in the armband then determines which part of the display is activated by the user's touch. This is the inner view of the armband, and the software matches the sound frequencies to the specific skin locations by allowing the system to determine which skin button the user presses. Process. First of all, the projector displays the image on the arm. Then we tap on the arm with the finger. Vibrations will be produced and passed through the bones onto the skin, which detected by the detector on the armband. And finally, electronic signals will be produced in form of music. Observations. 10 channels of acoustic data generated by 3 finger taps on the palm, followed by 3 taps on the wrist were taken. The exponential average of the channels is shown in red, whereas segmented input windows are highlighted in green. We can note how different sensing elements are activated by the two different locations, which are palm and wrist. We employed 3 input locations as shown in the figure in order to evaluate the result of the Skinput. First one, fingers. Fingers with 5 location input with sensors above the joint part of hand or elbow. The armband will be placed approximately 7 centimeters above the joint part. Second one, whole arm. Whole arm with 5 locations of Skinput with sensor present on the lower part of the elbow. The armband will be approximately 3 centimeters aside from the elbow. Third one, forearm. Forearm with 10 locations of the Skinput with sensors overhead of the elbow. The armband will be placed approximately 7 centimeters above the joint part. We can observe the accuracy at various random positions for tapping. The accuracy for 5 finger locations is high and approximately of an average rate of 87.7% is obtained. The accuracy for whole arm locations is relatively high compared to the accuracy of the forearm, and as well as approximately an average of 95.5% is obtained. Applications: Skinput can be used in the mobile, gaming, and iPod. Advantages: we no need to interact with the gadget directly. If you are using a keypad mobile, you no need to worry about the buttons. If a person is paralyzed or physically disabled, we can even implement this technology on that person. The feature of Skinput technology provides a projected graphical interface on the skin so the person who is paralyzed or physically disabled can use it easily, like making a call, playing games, controlling music player, etc. These were some of the most frequent skin-specific gestures for emotional expressions. All gestures were performed on the forearm and also some were performed on the back of the hand, and the palm were the frequently used locations. While the upper arm and the elbow were rarely used, this means the values for perceived ease and comfort of use for each location aggregated for all input modalities. Disadvantages: many people won't wear a big band around the arm for the whole day. It is also quite expensive to use, and not enough research has been conducted on possible skin diseases which can occur by using this skin put armband. Percentage accurate versus BMI graph. Accuracy will be significantly lower for the participants with BMIs above the 50 percentile. Like I said, modern problems requires modern solutions. We can even overcome the limitations. As extensive research is going on currently on the skin put to make the armband smaller in order to extend the accuracy level and incorporate more devices with the system. Skinput technology, however, has the higher chance of acceptance in the future. Skinput doesn't require any external device except the armband, so if we find a way to reduce the bulky size of the armband by using more flexible and thin band and also by increasing the electrical complexity, we can make it portable to use. Let's understand Skinput better by watching this video. In this video, we can observe a guy playing Tetris using Skinput technology. He is tapping at various points to change the directions while playing the game. The most profound achievement of the Skinput is proving that the human body can be used as a sensor. A person might walk towards their home by tapping on the palm to unlock the door, and then tap some virtual buttons on the arms to turn on the TV and start flipping the channels. Imagine how cool it would be. Yes, Skinput makes it possible. These are some of the references which helped me while preparing my video. That's it for the video, guys. Thank you for listening.